I think you are enjoying your study. Now, we have discussed many topics in previous videos. You have studied them, and now we'll be able to understand the basic concept of chemistry. Now, today's topic is the gas laws. We have studied many properties related to states of matter. As you know, there is three basic properties of gases. Now we know that there are three states of matter: solid, liquid and gases. When solid is heated, its temperature gradually increases, and at a certain fixed temperature it melts and changes to liquid. Further, when liquid is heated, its temperature gradually increases, and on reaching to its boiling point, the liquid will start to change into vapor state or gaseous state. Now, how is the change taking place? Actually, it is due to the amount of kinetic energy increasing with the molecules. Students, as we know that temperature is the average kinetic energy of the molecule. So, when a substance is heated in any physical state, it may be solid, liquid or gases. When a substance is heated, the average kinetic energy of the molecule increases, and then they start to move away from each other. That is, we can say that thermal expansion takes place. This is why when solid is heated, the intermolecular space increases, molecules move away from each other and they start to flow. Similarly, when liquid is heated, further more kinetic energy increases, and when the kinetic energy of the molecules is able to break the force of attraction between the molecules, they start to escape from the surface, that is, they change into gases. So there are basic three states of matter: solid, liquid and gases. Now in this part we have to study the gas laws. The chapter name is gas laws. Topic for it is gas laws. Now, first of all, we have to study here about the gases on the basis of its kinetic model. In gases, the particles, the molecules move randomly with all possible speeds in all possible directions, due to which gases have neither definite shape nor definite volume. As well as you know, due to high kinetic energy, the molecules of gas can easily break the force of attraction. So there is large intermolecular space between them, and the intermolecular force of attraction is low, small. Since in gases there is large intermolecular space, large volume for a given mass, so the gases have low density. So these points can be summarized point-wise, like you see, that is, in gases particles mainly molecules move randomly in all possible directions with all possible speeds. All possible speeds means all the molecules will not have the same speed. Then the intermolecular force of attraction, the intermolecular force of attraction is very low or weak. Next, the intermolecular space is very high. That is, the molecules are placed at very large distance. Next point related to it is they have high kinetic energy. They have high kinetic energy with the molecules. Depending upon these 3 points, there is the one important property of gas, that is they have neither definite shape nor definite volume. It means that, now again you can see here, in gases there is no definite shape nor definite volume. Means the gas will acquire the volume of the container, the shape of the container in which it will be stored. Gases cannot be kept in open because the molecules start to spread. Molecules will start to move in different directions. Next, they diffuse at faster rate. Now there is a term called diffusion. Diffusion means intermixing of particles of two substances kept in direct contact. Means when two substances are kept together, their molecules move and enter into the intermolecular space. Hence, they get uniformly mixed. This is called diffusion. So again, what is diffusion? You can write here: the mixing of particles of two substances kept in contact is called diffusion. Now you see that in diffusion the molecules move from region of their higher concentration to region of their lower concentration until the concentration become uniform. So since in gases there is high kinetic energy, there is large intermolecular space, so the molecules can easily mix with each other. So the mixing, that is the rate of diffusion, is faster in gases in comparison with liquid and solids. Now next, they are highly compressible. Means the gases can easily be compressed. That is, when the pressure is applied, the molecules of gases will come closer, the volume will be decreased. That is, they are compressed easily. So gases are highly compressible. So these are the different basic properties of gases. Now we see, students, that is, in gases there are three standard variables. Means the behavior of the gas is affected or described by three basic variables, standard variables called temperature, pressure and volume. Means a gas is described by using these three characteristics. So now we can describe here one by one the three variables or factors along with their units. Now we know that the standard variables for gas laws, or we can say that is the standard variable to describe the behavior of gas. Under normal conditions of temperature, pressure and volume, the behavior of all the gases will be the same. Now here we are going to describe these three variables, that is temperature, pressure and volume. These are three variables. The first point, or that is the standard variable which affects the property of gas, behavior of gas, is called temperature. Now, as we know that temperature is the degree of hotness of a body. Now, according to the kinetic model, it is the average kinetic energy of all the molecules of a substance. Now, students, we know that when heat is supplied to a body, the kinetic energy of the molecules will increase. The temperature of the body will increase. So the molecules will tend to move away from each other, causing thermal expansion. So when temperature is increased, the volume will increase if the pressure is kept constant. At the same time, if we take the gas in a container, now on increasing temperature, the molecules will have increased kinetic energy. As a result, they will collide with the wall more frequently, exerting more force and more pressure. So if the temperature is increased, the pressure will increase. So we see here, that is when temperature is increased, the molecules start to move more away, increasing the volume at constant pressure. Means we see here that temperature is directly proportional to volume, or we can write here volume is directly proportional to temperature. At the same time, we see that if when temperature is increased, the molecules collide with greater speed with the wall of container, hence pressure increases at constant volume. So we see that the temperature affects volume and pressure of the gas. Now, students, we have to study its units. Temperature, the unit of temperature. the most commonly used unit of temperature is degree Celsius. Degree Celsius. Celsius. That is degree Celsius. Then there is another unit, a scale, Fahrenheit. Fahrenheit. It is taken as this one, written like this. Now, although conversion is not needed in this chapter, but it must be known to you for your knowledge, that is 1 degree Celsius is equals to 1.8 degree Fahrenheit. Now, we will study it in more detail when required in higher class. Now, third, SI unit. SI unit of it is Kelvin. SI unit of it is Kelvin. Now, how is this scale designed? Now we see that when gas is cooled, when temperature of the gas is decreased, gradually it is found practically that at minus 273 degrees Celsius, the molecular motion of gas ceases. Means this is the lowest possible or attainable temperature. This is the lowest possible or attainable temperature. Now, although this is only a theoretical value, the reason is that no gas can have zero volume. If the volume will be zero, matter will not exist. In that case, it is only a theoretical value. So since at this lowest level, lowest temperature, the volume becomes zero, so this lowest temperature is regarded as the basic, that is the zero value for the Kelvin scale. So it is 0 Kelvin. So minus 273 degrees Celsius is taken at 0 Kelvin. So now we write here absolute zero. Absolute zero is taken as 0 Kelvin. That is the temperature on Kelvin scale. Temperature on Kelvin scale at which all the molecular motion of gas ceases is called absolute zero. Absolute zero. It is 0 Kelvin. It is 0 Kelvin or 0 K. So students, you know that 0 Kelvin is equivalent to minus 273 degrees Celsius. But whenever you are asked that what is absolute zero, you must answer for 0 Kelvin. 0 Kelvin is equal to minus 273 degrees Celsius. But if the question is asked what is absolute zero, you will not write this answer. This is not zero. You have to answer for 0 Kelvin. Now, one more thing, students. Whenever we have to perform calculation for gas, the temperature should be converted to Kelvin scale. Now, we will study Kelvin scale in detail. Like you see, that is, what is the significance of Kelvin scale or so on. So, you write here Kelvin scale, also called absolute scale. That is, the temperature on Kelvin scale will be taken as absolute temperature. So we write here the temperature on Kelvin scale is called absolute temperature. temperature in Kelvin on Kelvin scale is called absolute temperature. Absolute temperature. Now we see that for gaseous calculation, the temperature must be converted to Kelvin scale. For gaseous calculation, temperature should be on Kelvin scale. Now, why it is done? So, first of all, you see, if there is a temperature on Celsius scale as T degree Celsius, then on Kelvin it is T degree Celsius, T plus 273 Kelvin. That is, temperature should be converted in Kelvin scale because 0 Kelvin is equals to 273. So, whatever may be the value on degree Celsius above 0, it will be added to the 273. So this is the conversion. Now one more thing, student, we write here significance of Kelvin scale. Now what is its significance? Why should we convert it in Kelvin? First point, all gases obey gas laws on this scale. First point. Next, that is, it always gives positive reading of temperature. Like you have seen, that is in Celsius scale, it may be below 0 in negative up to minus 273 degrees Celsius. Fahrenheit may be in negative, but Kelvin will start from 0 because this was the lowest temperature. No matter can exist below that temperature. And the third one is that, third point for it is that is this scale is independent of thermal properties of gases. So these are the three basic conditions due to which we always perform gaseous calculation on Kelvin scale. So students, this was related to the topic temperature. Clear? Now the next part, next physical variable, standard variable is the volume. Second is volume. As we know, this is the basic definition. Volume is the space occupied by a body is called volume. The space occupied, the space in which the body is kept, is known as its volume. Now you see here, it is measured in different units, like you see, that is, its units are, first of all, first unit we can say, suppose we take cubic meter. 1 cubic meter is equals to 1000 decimeter cube, which is equals to 10 to the power 6 centimeter cube. Next unit can be taken. Suppose we take liter. 1 liter is equals to 1000 ml or 1000 cubic centimeter. Now, in this relation, we see that 1 liter, hence 1 cubic meter is equals to 1000 liter. So we can use these units wherever required to describe the volume of the gas. Now, the third variable is pressure. Now, as the definition of pressure is given in physics chapter, that is the force exerted by a body on unit surface area is called pressure. Now, when a gas is kept in container, the molecules move randomly and collide with the walls. The average number of molecules colliding with the wall on unit area of the wall always remain constant. Therefore, we say that gases exert equal pressure in all directions. So, whether the pressure is asked at the bottom of the container, on the side of the container, on the lid of the container from inside, in all cases, in all directions, it will be the same at given condition. Now, so pressure, the thrust or force. Thrust is the perpendicular force acting on the surface. So we generally use thrust word for the pressure. Thrust or pressure exerted on unit surface area. Now, our Earth is surrounded by a thick blanket of air, that is called atmosphere. Now, even the particles of air exert thrust as the weight of it on the surface of the Earth. The average pressure exerted by the air column on unit area of the Earth is known as atmospheric pressure under the gravity of 9.8 meter per second square. Means, when we say atmospheric pressure, the pressure exerted by column of air on unit area of Earth is called atmospheric pressure. Now, in normal conditions, we see that 1 atmosphere, the measurement, or we can write here units, 1 atmosphere, in short it is written as ATM, is equals to 10 to the power 5 Newton per meter square, also written as Pascal. SI unit of pressure is Pascal, which is compared with atmosphere or 1 atmospheric pressure. Now, further, we can write here again that 1 atmosphere is equals to 760 mm of Hg, that is the mercury column. The length of mercury column in the tube of 760 mm length will exert the same pressure as the 1 atmosphere. It is equals to 76 centimeter of mercury or 0.76 mm of Hg, millimeter of mercury. One more unit can be taken, that 1 atmosphere is equals to, there is another unit, 760 torr. In some question torr unit is also given. So while handling the problems related to gas laws, we will have to remember the units of temperature, pressure and volume, then we will be able to find the answer. Students, you must remember, that is, while comparing the volume of two different gases or gases in two different conditions, you must remember that the units should be the same. Like suppose in one condition the unit is given in atmosphere, but in another condition the unit is given in centimeter of mercury or millimeter of mercury, then you must convert the first unit also in millimeter of mercury, or millimeter of mercury should be converted into atmosphere, means the same unit will be used such that the calculation will be done accurately. Clear, students?